Hi guys, Mr. Johnny here. This time I got something else to repair. A car battery charger. So first thing first. It is pretty lightweight, so it is a switcher. Let's have a look. Have some Orion brand name, PW320, automatic or manual. Have some mains indicator and some wanky LEDs which I do not know what they say. And this knob is current setting. I mean, like, you set the current with this one. Less or more. Less or more. This kind of deal. It has a fan on the back, which we can test kinda by giving it a jolt, seeing if the fan moves. And it does, so will spin reasonably easy. The unit is very dirty, so it lives in the garage. Screws are corroded, so the garage is rather moist. We plug it in. I'm gonna turn it on. Hear that? Rather annoying noise, and it changes when I flick this, and this does too. The fan speeds up and this changes, but there is nothing on the output. Nada. You can see the SIM connected, black probe here, red probe there. Regardless of the position of the knob, or the switch, or both, we do not have anything else than about 60 millivolts or some weird ass offset. The problem might be very simple. Oops. The problem might be that the fuse is blown on the output. There is no accessible fuses on the outside, so let's tear it apart. To do that we need to take 4 screws out on the bottom. I ain't gonna bore you with that. This thing is Russian made, apparently. Well, the components are definitely Chinese, of course, but the thing supposedly is made in Russia. Yes, it is a switcher, no surprise there. What the? We have a little, what looks like a auxiliary power supply. Let me zoom in on that one. So that's probably a little auxiliary power supply here, main supply. And why I don't think that it is a common mode choke, because I see 2 places where a common mode choke should go. See these 2 jumpers and these 2 jumpers. Ay ay ay. Well, what can I say? It is a... I like to cobble stuff together. I mean, like, I have a beautiful example laying just on a bench, as you can see from this power supply, which is beautifully made. But at least I don't sell these, alright? I made this for myself. I have no guilt here. This thing is perfectly safe if you use it wisely, and I do. But, man, if you're like selling this stuff, you should make it look a little bit better, I think. First thing first. My general impressions are not that great about this. Not only the layout is quite crikey. The capacitor, bulk capacitor, is 350 volt rated, which is bad, because we have 240 volt pretty much mains, and that peaks out at, you can see it's about 340 volts, and the capacitor rated 350 is not good. On the input we have a fuse, which doesn't seem like it blown one, plus I have something going on, so it's not blown. Have a 10 ohm thermistor there. 2 places where common mode chokes supposedly should go. A little transformer, which is very weird, which kind of snakes all over here to this device, which might be... no, it's alright. which might be a transistor for the little self-oscillating flyback that creates a power for the TL494, I think. Yep, not a big surprise there as well. If you can see it, oh, that is. Let me try to focus on it. Oh yeah, you can see it beautifully. TL494. So that's a auxiliary supply for the chip. It's a main transformer. That's apparently the shunt, alright. Quite a hefty output inductor, nice. 1000 microfarad 25 volt output capacitor, adequate, although I would like to put two in parallel. Could be smaller, like two 470s in parallel, but you need to parallel them because you have quite a large ripple current. Not in a half bridge, which is what this thing is, but still a good practice. So the half bridge transistors are these two. And no, sorry. Wow, what the hell? I really don't know. This is a rectifier, because you can see how it's done. The anode's outer legs are connected to the transformer there and there, as you can see. 7 minutes already. What do I do? Oh, what the hell, I'm gonna make this a detailed video. If you don't like long videos, just don't watch it. All editing I will do is just cut out some parts that I rumble for no apparent reason, like this one. But I'm gonna leave this one so you know what's going on. Let me take the board out. Again, I can assume that the leads are fine, but yeah, do not assume, alright? Yeah, it makes continuity, alright? That's fine. I did not think that it had a problem there, so, but still a nice way to check. And alright, the fan is a bitch to get out. What? Oh, there is quite a lot more waiting for us on the other side. Look at that. Let me glance at it for a while and tell you what is what. Okay. I'm quite... Looking at it, I am kinda suspecting that this thing might be a self-oscillating device of some sort. Because I have a diac right there. That does not make me feel all warm and fuzzy inside. Oh boy, oh boy. Oh man, what the hell is this mess about? What is that? I mean, like, what does those parts do? But what I can say straight away, here, see? Nice stuff, discoloration and stuff like that, and some rather nasty corrosion right there. And you can see what I talk about the corrosion. That high value resistor is quite damaged, 750K. This is a quad op amp LM324. If you can see it, 324 it says here. There is a place for another SOIC. What is that? 3, 6, 8, 16 pin SOIC. Bunch of parts across. A buttload of diodes, where the two main transistors are. And here is that part which I told is a rectifier. Remember its position here. See that part right there? I told you that the outer legs goes to the transformer, which are anodes. The common cathode is here, which goes to that big ass choke, which in turn goes to the output cap, This is two leads. You can see right there, there's a big ass chunk. I'm afraid it requires a little bit more investigation, because right now it's quite a mess. I need to figure it out what is what. I'm still quite amazed what is that transformer is all about, because I can see very inactive parts that is supposed to switch it. Weird. Oh! Such a shame to believe in escape, a life on every face. It's a drive transformer, which gets its power from the TL494. Seems like without any transistors, which is kinda crikey, but alright. It might be happy with that. And then it drives bases of the two transistors on these two heatsinks, and then the rectifier is right there, and then I have no understanding what is that about. Maybe it's a polarity protection diode, which is just a bunch of diodes connected cathode to the positive output. In case you connect the battery backwards, it will contact and blow the fuse, which there are no fuses on this circuit, except the mains fuse. What the hell is this about? Oh wow, it is an IRF Z48. All three of them. What the hell is that about? It's kind of fantastic. I don't know if you can see it, but let me try to. Alright. IRF Z48, as you can see, all three of them are the same. Badly oxidized. Oh man, that's a mess. So yep, I think that's how it works. It is kinda similar to Type AT computer power supply, which I took as a basis for the power supply in my soldering station, which is right there. I'm not pointing to the link, I'm pointing to the physical station, which is to my right. Well, what can I say? Let me investigate, to save time, because it's already 15 minutes and you're bored by this time. Well, what can I say? I found a few parts which look shabby. This resistor looks a bit sad, and that one does. That one you can see resistor capacitor across the two anodes of the rectifier. So that's an RC snubber. It gets hot because this capacitor is chosen too big and snubs down way too much. You don't need excessive stuff. You really need to practically find the sweet spot, sweet value, or just calculate it. The calculation is very simple. You can see it in my other video, link to which I'm gonna include in the description below in case you are interested in. Holy small. That might be the reason. Well, this circuit is a mess, isn't it? I'm sure I can fix it, but can I reverse engineer it? I don't think I would, but I don't know. It seems like incredible hassle. This section with the MOSFETs here is quite intriguing, because what the hell they tried to achieve there, I don't quite understand. Those are in-channel MOSFETs, I can guarantee you that. IRF Z48s are in-channel MOSFETs. It's kind of a bigger brother of IRF Z44. I'm not surprised that this thing died, because it looks like this thing was almost floating. Alright. You can see how badly corroded the things are. You can see how crikey the joints look. You can see how much corrosion there is on these poor resistors and stuff. What the hell is that? Since my problem, I think my problem is most likely in this section with this weird ass configuration there, because this resistor is burned. definitely seems to be, and I cannot really distinguish what value it was, so that's quite bad. I don't know what I'm gonna do with it. Really, I'm gonna try to fix it and then show you quicker, because this video is gonna take absolute ages. Nobody will watch that. One or two may actually like to watch that kind of long videos, but majority of you just don't give a flying